In this video, I'm going to show you how to use one more ISO 15693 tag, and that is the tag it HFI+. This tag is manufactured by the Texas Instruments. So in the documentation, I could see there are three types of tag it. The first is the standard, the HI+, the one I'm going to discuss in this video, and the Pro version. So I don't have access to the standard and the Pro tags. So what I have read from the documentation is the standard tag has a less memory compared to the plus tag, and the Pro tag has got, it's very similar to the standard tag. However, this has a password. It is a password protected tag. So what I'm saying now is purely I've taken from the documentation. So it says any locked block can be returned using a password. So since I don't have these two tags, I would not like to speak anything more than what I mentioned now. So we're going to discuss the memory organization, how to read and write to the blocks, the AFI and DSFID, read and write and lock as well. And I'll be using the reader writer called OmniKey 5421. And this is the same reader writer I have used in my previous videos where I discussed and showed you how to do almost every operation of the iCode SLI tag. So what I noticed about these tags are they're not easy to find on internet. So I somehow found a seller in eBay, and I bought a pack of 5 tags. And here, as you can see, there's no mention about whether this is the tag IT plus or a standard or a Pro. So if you look at the price wise, compared to the MeFair classic tags, these tags cost you more than £1 each. Now if you go to internet, you can get this document from the Texas Instruments website, and the memory structure is pretty simple. So if somebody asks you what is the tag it HF plus, probably you would say that, so this is ISO 15693 tag with 64 blocks of memory, and each block is 32 bits. It has got the DSFID, the AFI, and it has a UID. The one interesting thing which I saw in this tag is there are 2 log bits. So documentation says the first log bit called F, it's a factory lock, and the other one called U, this is the user lock. I know in theory what this factory lock does. The documentation says some of these data blocks can be made to lock or can be locked during the production. So probably some big software project might order say 100,000 or 1,000,000 tags, and they would want the tag to come with some initial data and the blocks are locked. So because the tags what I got has got no locks in the factory log bit, and also I just don't know how to test this. However, we are going to use this user lock. The lock concept is very similar to what we have seen in the previous videos about the iCode tags. And so from the developer's point of view, we just have to know this memory structure and also the various commands. Again, we don't have to worry about these commands in detail because we are using a reader which which basically now hides out all the internals of this command. And I've already connected the OmniKey 5421 reader writer. If you look at the commands, all these commands are they are very straightforward. So here we know that all these ISO 15693, they do have inventory, they do have the stay quiet, and the select tag and the reset to ready. All these commands are related to the inventory, and we don't do the inventory type of commands when we use this OmniKey reader writer. And other commands are, you can read a single block, write single block, lock a block, read multiple blocks, write multiple blocks. And you got write AFI, lock AFI, write DSFID, lock DSFID, get system information. This is the command probably used to find out the UID and the value of the AFI, sorry, the value of the DSFID and AFI as well. And this command is to get to read the security status of the multiple blocks. However, because we use a device that provides us a very high level function, we just don't know what are the commands, the internal commands are used. Say for example, we have seen in previous videos how to read in bulk. So, but I'm not very sure whether the device actually uses the read multiple blocks as a single command, or does it use a number of read single block. So in the future videos, when I start using these raw commands, we are going to see how to use all these commands. Until then, it is very easy to work these type of tags. And there are two more custom commands called write to blocks and lock to blocks. I'm not very sure what these commands are. Probably in the future I might find what they do. So you can see I've connected my OmniKey 5421 reader writer, and the software I'm using is the version 1.5.1. So if you already have this software, you will get the update automatically. If you don't have the software, you're going to learn a lot of things from this video. So I'm going to place a brand new the target, and I'm going to choose the contactless interface and choose the ISO 15693. I'm going to activate, and you can see all the commands here. And as we did in the previous videos, you can read the AFI, you can read the DSFID. So when you buy a new tag, you might get AFI with value 0. I have already played with this tag, changing this AFI and DSFID. And this tag does not have the EA's functionality. So even if you try to get, you will get an error message. And however, the good thing about these tags are you do not have to reactivate by sending when a command that is not valid is sent. And the documentation says these type of tags, they just ignore invalid commands. They just be silent. The memory size, this has got 64 blocks. We have seen that in the documentation. The IC reference, all this information you can fetch it. So we have seen in the previous videos all the commands of OmniKey that are used to get this. And I'm going to try to read, because this tag has a huge memory. This has got 2048 bits. I'm going to use a bulk read operation here. I'm going to click on read. You can see that a lot of flashing going on here, and so you have read the entire 2048 bits or 64 blocks. And if you look at the commands, we have seen this in the previous videos. I have used the bulk read operation, and here I am reading the 63 blocks. After that I am reading one extra block, because the length, because this, when this command, this is an ISO read binary command, you can specify in 1 byte the length of bytes you're going to read, and you can set this maximum as 255. However, I have to read 256 bytes, and for that reason I'm reading the first 63 blocks. After that, the remaining one block. Now there is also a command where you can read more than 256 bytes. Probably I have not tried that, so I don't want to mention about that. Now we have done the reading, and this is what after the read is done, I'm getting the security status of every block, and the first byte tells the value of the locked bit. It is all 0, so it's not locked. I'm going to do some writing. We have seen you can go and edit here. I'm just going to quickly show you some of these operations we did in the previous videos. I can just go and clear this. Okay, so I can write. The write is successful. You can also see when the write is going on, the LED flashes. Now I'm going to show you something which I've added in this version. So we are going to see how the bulk read and write is bulk write is done, and for that I'm going to use some lorem ipsum characters. So I'm going to copy paste in a lorem ipsum. Now first I'm going to transfer from this text box to the right side of this into the grid. So I'm going to copy this starting from block 1, and I'm going to keep this as byte 0. Save. So everything is copied here. If you go to the ASCII mode, so everything is filled with lorem ipsum. However, the data is still not returned to the tag. So I'm going to use transfer everything from block 1 to block 63, block 1 to block 63. This is the bulk write operation. So I'm going to write. You can see the LEDs are flashing. Looks like the write operation is in progress. Now after that, if you see this message, if you look at the command I have sent, this is a ISO update binary command, and this is a bug here. It's not a 4 byte. This is I'm writing 200 and this was the command we did for the first block, and here the update binary we are writing 252 bytes. Now as I mentioned before, is this device using the write multiple block command of ISO 15693 or not? So probably now we have to check with the OmniKey development team. However, the writing is done. I'm going to try changing these AFIs. So we have seen this in the previous videos. Just try to set. So it's set right. This is the command. It's the put data command to change the value of AFI. I'm going to say FA, set it, and you can't change anything. Now I'm just going to close this screen and try all over again, reactivate, get that so the write was successful. I'm trying to write in DSF ID is also written, and if you're using this software, you have to first get the memory size before you hit this read tag. Click on the bulk. There's something else I would like to mention here. When you decode this UID, the documentation clearly mentions, we know that the first E0 refers to the ISO tag for ISO, I think, value for 15693 type of tags. And you got this manufacturer code 07, this is a TI, and the product code 00, this is the byte. 00 means it's target HF1 plus. So the documentation mentions about the other values and what it means. The remaining values are the serial number. So we have seen how to write. I'm going to try the lock here now, and keep in mind the lock is a one-way locking. So once you lock a block, you cannot unlock it. Now we are using the user lock. So remember, this tag has got two types of locks, the factory lock and the user lock. And factory lock, we don't know what they are, but the best example for factory lock is the block where the UID is stored. If you remember the documentation of this UID is also stored in two blocks, and those two blocks are factory locked because of that you cannot change the UID. So I'm going to lock the first 5 blocks and hit this update. You can see some flashing going on there. I have sent 5 lock commands, one after another. There's no single command to lock multiple blocks, and to make sure this is indeed locked, I would close and try again. Okay, and I'm going to write and see if the lock works. So I don't have to change, I just go and hit the write. The write failed with the response SW1 62, SW2 as 82. So this is a invalid write operation. So the lock works. So I don't want to lock everything here. So we have seen how the lock, and you can read the lock. When you hit this button here, what the software does is it just goes through every block and reads the security status byte of every page. Sorry, look at that. So there's no single block, and I'm not again, the documentation we have seen a command called read multiple. Now if you see the documentation, there is a command called get multiple block security status. If you see the description of this command, it means this command can read the value of the locked bit for more than one block in a single command, whereas this command is not available as a higher level command in this OmniKey reader what I'm using. So there's one more feature in the software. This is nothing to do with the tag. You can read everything from the tag here. You can modify and write it back. Say I would like to modify the last line. I'm going to take some more lorem ipsum characters. So copy here, and I would like to transfer everything back to the memory, or you can just take it out. I'm going to transfer this part of the data into the memory starting from the block 40 and say byte 3, byte 2. There's no byte 4 here, sorry, and it has saved in everything from the block 40 onwards from here. Okay, it is, if you look at here, it starts from O, only O starts from the 2 here, probably sorry, there's a space here as well, so it starts from the space and followed by the next byte is O, and so on. And I can transfer the content of block 40 to 46 and write it, and so this transfers only the 6 blocks. And also here as well, I'm converting all the data from the 6th block and sending as a single the update binary command, passing 28 bytes. So as you can see here, using this tag it ISO tag is also pretty easy, and the main thing here is it's easy because we are using this this ReadWrite.